Thank you, everybody, for joining us. Greatly appreciate it. So today we're going to be talking about creating components using the library editor. I decided to make this one just slightly different because what we're going to be covering is how to create components in a faster manner. So we've had some previous webinars in which we actually go step by step in creating a component. But today we're going to talk about some tools that are available in the library editor. My name is Edwin Robledo. Usually everybody calls me Ed. I've been part of the Autodesk support team for Eagle for many years. I was part of the acquisition when Eagle got purchased by Autodesk a few years ago. But I've been lucky enough to be working with Eagle for approximately the past 20 plus years. And with me today is Jorge Garcia, another one of our support specialists. You want to say hi, George?
Hi, everyone.
Excellent. Thanks for that, man. Jorge and I have been working with Eagle, and we were both part of the acquisition by Autodesk when we came over. Now, before we actually begin the presentation today or the demonstration today, I'd like to talk a little bit about the library. Just in case for those that don't have a full grasp or understanding of exactly how our library editor works. Okay, so our library editor is basically a platform. It actually consists of multiple editors within one platform. It has the schematic symbol, the footprint, and the device. Once you combine them all together, you have your library, you have your asset, your actual component. And let me show you a little bit about that. The schematic symbol is where you're going to actually create a logical representation of the component. It's going to consist of the pins, and each pin you could assign it a particular function and direction as well. This is the logical aspects of the component. Then we have the package editor. And the package editor is where you take into consideration the actual physical aspects of the component when you're going to put it together. How big the component is, the lead spacing or the pad spacing, if it's through hole, if it's surface mount, and so forth. And once you have your symbol and you have your package, you put it all together in something called the device editor. Here you're going to actually combine that schematic symbol that you created, select the footprint that you created, and assign each one of those pins on the schematic symbol to one of the footprints. This allows the movement between or the design capabilities of when you're working in a schematic with a circuit board. It knows exactly how to transfer those connections from the schematic to the board, and modifications done to the schematic will happen in real time. And all of that works when you're tied with this type of structure. Now, I just want to let you know, when you place a component on a schematic and you're using it, the entire device goes with that onto the schematic. In other words, if you do no longer have the library, you don't have to worry because all of the information for that component is now totally in a part of that schematic. Okay, so you don't depend on having the libraries when you already have a schematic. Okay, so if you're sharing your designs with somebody, you don't have to actually send them the libraries. It's not really necessary. Just wanted to make that clear. Okay, now let's break this down a little bit. In the schematic, we actually place our pins. We assign it a name, and usually the name of the pins is going to be depending on their function. We assign it a direction as well as a function to each one of these pins. This is the common sequence, and we just use the pin, put them each one down. Now, there's a couple of tricks we have for creating schematic symbols that just make the process a little bit faster. One of them is called Smart Paste. Smart Paste actually allows you to select the names from the manufacturer specification sheets and actually paste it. This is a lot easier than just placing each pin individually and then going back using the name command to name each pin. This just makes it that much easier. Okay. Now, another option that we have is called Pin Array. When you're in the schematic symbol editor and you select the pin command on the menu, on the toolbar, which always is constantly changing, you'll notice that you get the pin array option. This actually allows you to create a schematic symbol a lot easier by selecting if the pins are going to be on the left, on the right, top, or on the bottom, how many pins you have. You start index if you want to include the name and the value. If you wanted to generate the body of the component, you actually select the generate rectangle. Jorge is going to be demonstrating this shortly. So we're going to be going over these. Now, in Smart Paste, We also have the option of creating a spreadsheet. Each one of the functions of each one of the properties of the pin can be created as a spreadsheet header. Now, when I copy paste all this information onto my schematic, each pin will have the appropriate size, the appropriate function, and direction. This just makes it a little bit easier. It might be a little cumbersome when you create your first spreadsheet, but you could continue reusing the same spreadsheet over and over and over. Yes, and then the only thing you need to change is actually the names of the pins eventually. Okay. Now, let's go and okay. Now let's talk about the footprint. The footprint is actually the physical aspects of the component. You're going to be getting the information from the manufacturer specification sheet. You're going to select if it's surface mount, if it's through hole, see the lead spacing, actually set up your grid, that way you could get the appropriate spacing, and start adding your pads one at a time, and you can name them according to their position. That's how pads go. But there's a couple of tricks to making this a lot easier. One of the tricks we're going to be talking about today is about the package generator. The package generator actually creates a 3D model and the footprint all in the same step. You could select from the IPC compliant templates that are already included, but we've gone beyond and have a lot more than IPC compliant parts as well. So you could select components from the templates, type in the values from the manufacturer's specification sheet into the template, and it will build a component for you. Also, you have the option of creating a footprint by using the pad array. The pad array is supported by through-hole and surface-mounted parts. When you select the pad command, either surface mount or through-hole, the pad array option is going to appear on the parameter toolbar, and at that point you could actually select your spacing, how many pins you have, if you want on the left and the right, top or bottom, and if you wish to have the silk screen created for you as well. Okay. Now, once you have your schematic symbol and you have your footprint created, the final stage is called creating the device. This is where you actually select the symbol, select the package, and assign each one of those pins to one of the pads. Now, there's one more trick we have that I wanted to bring up. You see, Eagle actually has a very powerful tool called User Language Programming. We call it for short, we call it ULP. Well, one of the ULPs, one of the most intricate ULPs that we have in Eagle is called Make Symbol Device Package, BSDL. A BSDL file is commonly provided by the manufacturer, also called as the boundary scan description language, which is part of the different options that are available as a hardware design language. The ULP can interpret the information from this BSDL file and build a component for you. You need to provide some information, of course, from this file before you could actually get it created. The nice thing is that it's possible it will create the schematic symbol, it will create the footprint and the device all from the BSDL file. And we'll be demonstrating a quick example of that today as well. You know what? I think I have enough. I think I bored people enough with the slides today, Jorge. Let's just go ahead and go live with Eagle. So let me stop sharing my screen.
Okay, awesome. So let's go ahead and start just with the big BSDL ULP. We're going to start there, and then from there we'll go to the other options that Ed covered in his. So we're here in the library editor. You can see this is a clean library. I'm going to click on the ULP icon, and the one we're interested in is called Make. Let me make this a little bigger so you guys can see it. Make Symbol Device Package BSDL. So BSDL files are usually used for large footprint devices. It's not strictly limited to BGA, but you usually will only see it when you're dealing with components that have very large footprints. So if you can find the file, usually the manufacturer will provide it. If your manufacturer has provided such a file, it'll make the creation of your part a lot easier. So I'm going to go ahead and double click it. This is what it looks like. Now this is a very flexible ULP. It does have a manual. You can actually, oops, it wanted me to find the manual. It does have a manual that ships with Eagle. You'll find it in the doc folder. But what you can do is you don't just have to use it with the BSDL file. You can actually use it to create a package on its own, similar to what the package generator now does. Obviously, the package generator is more flexible and a little bit easier to use in this, but this is still available. Same thing here with the BGA. And you can even make symbols as long as you specify the number of pins that you want to use.
So you don't really have to use the BSDL file. You could actually use it as well here.
Correct. This could be used to simplify part creation as well. But in this case, we are going to use a BSDL file. Now that the package generator has been created, probably easiest to use a package generator versus using this. But if you have a BSDL file, this is still the preferred way to go. So these are some BSDL files I got from Microchip for the DSPIC33 parts. Again, a lot of manufacturers will provide these files if you go and search for them. So I'll pick this one. Hit open. You'll notice that Eagle already processed it. The BSDL file contains a lot of information, so you can get pin directions already, the pads, what they're connected to. You know, it just processed this text file completely. You'll also notice it picked the right type of symbol. Now, one thing that you need to remember when you do this, like if I were to just OK it now, it's going to ask me to accept a BGA or the package parameter or existing package. Why do I hit cancel? Darn it. I'm hitting cancel today a lot. Sorry, guys. I don't know why.
Because you wanted to show the guys how to do it all over again. That's why.
That's why.
You wanted to give them a starting point again, Jorge.
Okay. So what you want to do is you can see it's picked the symbol the layout. You can change it. You can pick one of the other ones. For this type of part that only has 28 pins, the dual is a preferred way. You can use either one. I don't like the alternating. The alternating is useful for connectors or things like that, but for chips, this is a typical chip number scheme anyway. This device, because it's a SOP28, I know it's not a BGA, so it won't be accepting the BGA parameter. I go to Package. I will accept this package parameter. It already knows it's 28 pads. I accept it. If I wanted to use one of the pads that's in this library, I could do that from here. And then at the end, you have different tricks for processing a text file. Because you could bring in a text file of whatever format, and you can use these tools to kind of parse it. That's a bit more involved, and we won't go into that. But right now, we have everything selected. I'm going to click OK. Now, keep in mind, I didn't adjust any of these. So we're hoping everything is going to work out.
Now, those sizes would be provided by the BSDL file, or you would extract that from the manufacturer?
You would usually grab these from the data sheet.
Okay.
Yeah. So like right now, it may give us a package because I don't have the data sheet, so I'm not going off of it. But you would double check these values with the data sheet. That's what you would do. So we go to make. I'll click OK. And you'll see that it created this weird footprint here.
Hey, but that was pretty fast from doing it from scratch.
Yes, it is very fast, and if nothing else, you have a really good symbol.
You got a symbol. You got a basically a device. It's got to clean up the.
Yeah, you do have to clean up the package over here because again, I didn't go off the data sheet to fix the package parameters, so that would need to be corrected. But other than that, you do get a result. It has a link to it specifies what the data sheet, what the file is, how it was created. You can edit the description. So if you can get a BSDL file, that will make your life a lot easier. I had to do a 500, was it a 256 or a 512 pin BGA once? Did this in a few minutes. It was done. So this is really handy in those types of situations.
I've searched in the past, and I found once a site that just had a whole bunch of BSDL files from different manufacturers. It had a plethora of BSDL files.
Now what we're going to do is we're going to go into a few of the more manual options. Now we're going to go over these because these were introduced relatively recently, so we know that probably many users are not familiar with them yet, but they can save you a lot of time. So I'm going to go ahead and make this symbol, CCH03. I'll say OK. Yep. Now one thing you can do is you can do a smart paste to bring in the pins. So for example, I have the data sheet here. Okay. Now when you're going to do this, it works best if you use Adobe Acrobat or some other PDF reader that allows you to do a square selection, you know, or a bounding box selection. Because the more stuff you pick up, the less likely it is that the smart paste will work. So what we typically recommend is, in the case of Adobe, if you hold the Alt, you notice that the icon changes. So hold it, just pick the text that are the pin names. You do a Control C. Now you go into Eagle, the library editor, symbol editor, Control V, and it didn't paste. I was able to do it earlier.
You were in the command, because I think the command line was active. That's why I think.
Should still do it. Oh, there you go, paste. Yeah, you're probably right. It was a command line. And then we go and you get all the pins. And then you can just rotate them and reorganize them as you see fit. So that's one option. It can save you a lot of time, especially in high pin count components. Doing this will save you time. If you're on Mac or Linux, I do recommend to go with Adobe. If you're on, if you're on Mac or Windows.
I was about to say, because on Linux I usually use Ocular.
Ocular is the one we recommend for Linux because it does support having the square selection. So we do recommend Ocular for this. That's one option. Now the other option, which is the one that came in relatively recently, is Pin Array. So if we click here, here are all the normal pin options. But you also have this new one over here. If you click, you're going to see that it can basically do a symbol for you in one go. So you can build it up, obviously, in pieces. That's one option. In our case, we're going to kind of build it up completely. Because we know this part only has 8 pins, we're going to put pins on the left, pins on the right. Base name isn't going to matter because we're going to have to rename them. So I'll just say P. We have 8 pins. And we can say to include name and include value and generate the rectangle for us. So I'll say OK.
The rectangle is just that body, just to let you know that's that rectangle square body right there.
And we place it, and there it is. And now what we can do, I'm going to try to get fancy on Windows here. It's not the best idea, but I'm going to try it. So now what we can do is I'm going to go over here. I want to try to minimize this so that I can see the pin names. Now we can just use the name command. We'll say this one's HV. This is
I hope you realize how cool now is to use the smart paste.
Yeah, but the smart paste doesn't give you the finish shape with the
with the whole name, the value thing.
In this case, you can kind of flip a coin with either one. But I think that for this particular part, I'm done quicker doing this way because even though I have to rename, because the name command stays active and I already get the rectangle and the other features added in, I think it's a bit quicker.
If you notice, I just want to bring up the observation that Jorge placed the component with the origin of the page more or less in the center. It's just something that we usually do because when you're working on the schematic, it's really easy to find the origin of the part if you put it in the center. I've noticed some users, when I've received their files, they place the origin of the pin on pin 1. The problem with that, or on one of the pins, doesn't have to be necessarily pin 1. But the problem with that is that when you're going to select the component for either moving or deleting it, being on top of a pin, you'll have the net on top of it, and there's objects on top of it, so it makes it a little difficult to actually cycle select it. So we usually put it in the center. So any default libraries that you use from Eagle, you're going to notice that the majority are going to have that handle in the center.
Yeah. So that's our recommendation. Some people like to pin one thing. We don't judge.
No.
But it does, like Ed said, it can create some difficulties. So do so at your own peril. The center is a preferred way. So you can see, very easy. It'll create it for you. Now, if you like to be more hands-on and kind of draw things on your own, you can. There is a UOP you can use to bring in the name and value automatically on the appropriate layers, so you don't have to manually draw them in. And that one is called set name value, which is this one right here.
You're
Okay.
noticing that when you have the ULP dialog box open, it's really easy to search right there in that little field there. Okay.
Okay. So we got that. So now let's go ahead and check out the package generator. We've done a lot of webinars on this, so a lot of users are familiar with it. But let's take advantage and go ahead and talk about it and just show how we can use it to make a package for this symbol. So I'm actually going to cancel this. I'm going to go back to the table of contents view. Go to 3D package, create with package generator. Now this is a package generator that's up on library.io.
So yeah, this is accessing library.io, which works together with Eagle. Now, I need to clarify that when you're going to use the package generator, you do not have to have a managed library. Okay, that's one of the benefits of the. It will create the footprint and the associated 3D model, but you do not have to have a managed library. If you don't if you don't know what a managed library, don't worry about it. It's not that big of a deal. We'll talk about that later on a different webinar. But the nice thing is that you do not have to have a managed library to use the package generator. Okay.
Okay, awesome. So now we have the package generator up right here. This part that we were making the symbol for, the really simple STCH03, just comes in an SOIC package. So we're going to pick that. Okay, it only has 8 pins. Now, one thing we want to keep in mind is we see these letters here. These conform to the IPC standard. However, sometimes manufacturers do not conform to the same standard. So you have to make sure that you double check what each letter means, what it means to the manufacturer, and what it means in Eagle. So that's something to keep in mind. So let's just take a quick look, make sure. Okay, B and E matches, that's good. E and E1 matches as well. D and, okay, just D. A1 seem to match as well. Okay, what's A2? A2 is not used, but the A matches, so that's what's important. And do I have an L?
Yeah, you do.
I do have an L. L's match. All right, so I think we're good.
Yeah, it looks good, man.
So in this case, we don't even have to look back at this. Everything is matching. So we go over here to the table, and now we put in the values, and we just make sure that we enter them into the package generator as needed. So we get E. E is 1.27, 1.27. Capital E is 5.8 and 6.2. It's all coming off the data sheet. Okay, L is 0.4 and 1.27. Matches, nice. B is going to be 0.28, 0.48. Okay, the D, 4.8 and 5. E1, 3.84. Almost done, guys. Then we get the A. Capital A is just 1.75 over here.
Well, while Jorge is doing this, I just wanted to let you know that this package calculator is actually accessing library.io. This is where the calculator actually resides, and you could log into library.io using your the same credentials that you use to log into Eagle, and you could actually it's preview and see what you have, the content there as well.
Mm-hmm. So now, as you can see, it's generated the 3D model for us. It looks good. Everything is lining up the way we expect it. All of these values came from the datasheet. One thing we just want to talk about is density level. So this is something the IPC defines to be able to handle different manufacturing situations. So for example, you notice that the pads go a little bit past the pins of the component. The amount they go and how far they extend on each side, that's all defined by this density level of nominal. Now, if you had a really tight layout, you may not be able to afford having that extra space given up. So you could use least, which really tightens them up. As you can see, you get very little extra space. Or if you're going to do hand soldering, go with M. Now you get really light, nice long pads. It's easy to put a soldering iron there. So you can use these to kind of tailor the part to your manufacturing process. When in doubt, just leave it at default.
Yeah, the default I've noticed that works really good with the stencil and the reflow oven.
Yep.
It's a really good value, nominal.
So we're going to go ahead and leave that at nominal, and we're going to say OK. Package will be created. Yep, yes we can. Say OK.
So this is actually generating the 3D model as well as the footprint. So this is maybe one of the preferred ways of doing it nowadays. But I just wanted to give you, we want to provide you all the options.
You can see it's been created. You see this little gear. It's just letting you know that the thumbnail hasn't updated yet. Here we have our footprint. That was expertly created. It gets the name and value. It gets the pin 1 marker. Really nice. So if you can use the package generator, we always encourage that. It is probably the easiest way to get the package and the 3D model generated. Obviously, then you can join the symbol with the footprint and you'll automatically get the package.
The device, you mean?
Yeah, when we make the device, let's just make the device.
Yeah, just to make it, yeah. Show them the whole process.
STCH03. Say yes. Really simple. We add in the symbol. Again, try to center it on the crosshair. We go over here to new, add local. We pick this one, which is the one we just created. You can see the thumbnail's updated. We say OK. Prefix. Prefix is what's going to be used in the reference designator. So like if this were a resistor, you would use R. Capacitor, you would use C. For an integrated circuit, I like to use IC. Say OK. Value being set to off means that the part doesn't have a user-definable value, and it will default to the device name, which in this case is STCH03, which is the part name. So that's fine by me. If you do want to be able to adjust the value, just click on. And when that happens, the default value will be nothing, so it'll be empty. And then in the schematic of the board, you can define whatever the value should be. You'll notice that we have this yellow triangle letting us know that the pins have not been mapped to the pads. So we want to go ahead and do that. So I'll click connect. In this case, it's pretty easy because they match.
1-to-1 right there.
1-to-1 right now. So it's just about going in order. So
and you get that information from the spec sheet. Usually they have a little drawing with a little mock-up of the component and which each pad is going to be carrying.
For ZCD. I shouldn't have made the no connect. I just realized it's a no connect pin. It's okay.
That would have been nice. That way you could see the little X.
Well, I mean, I can change it to be a no connect style pin. I can change its I/O direction. So this is just taken from the data sheet. I say OK, and now the part is complete. Okay.
Notice that the schematic symbol on the left-hand toolbar, you'll notice a number on top of each pin. That's the pad that's been associated to that pin.
Okay. So now what we're going to do is let's go ahead and show you the use of the SMD array and pad array features. Those also came in relatively recently. They help with the manual creation. So I'm going to say SOP 8. Right, new footprint, yes. Okay, so we have this here. Click on SMD. Now what you're going to notice that we have a similar SMD array function here. We click it. You can see left. You can put the sides left and right. Again, base name for the pins. Again, I'll just put a P. There's 8 pins. I can have it, again, generate a rectangle, put in the name and value automatically for me. Now I want to get the spacing. The spacing from the datasheet on this is, let's look at the lamp pattern. Okay,
0.5
0.05 inches or 1.27 millimeters.
Yeah.
So we'll go ahead and put that, and then we put the space here. So really simple.
5.4.
So you go back to the library. I'm going to put dx. I'm going to put it in millimeters because it's just easier. So the dx is going to be 5.4, I think. Yep, 5.4.
Yes.
And then the dy is going to be 1.27. All right, starting index doesn't matter. It's going to get 8 pins. Say OK. Now we can place it wherever we want. Now we always encourage to try to center it as best as possible. So I'll put it like this right now. Did I put in the right? I didn't put in pad sizes.
Yeah. I was about to tell you.
Darn it.
Yeah, it automatically puts them vertical.
That's what I get for going too quick. Okay, left and right. Well, actually, we would have had to rotate them anyway, because it doesn't let you put in the dimensions of them. So it was okay.
Can't you put in the dimensions before going to the pad array?
Can I? Oh, yep. Yes, I can. Oh, I feel so crunchy right now. Let's see. 1.55 by 0.6. 5 by 0.6. Hit enter. Oh, I'm in mils. Oh, yeah, millimeters. Here we go. By 0.6. There we are. Now we do this left and right. P, going to put 8 pins. dx is 5.4. dy is 1.27 in millimeters. Rectangle, include name and value. So left and right, P, doesn't matter the base name because we are going to replace it. Just have 8 SMDs. Say OK. There we go.
Looks good.
Now it looks good. Okay. And in fact, if you wanted to, you could leave them that way because they are kind of in the right order. So that would be acceptable. Okay, but you can see it's a nice quick way to generate the part.
You could use a name command to change the pad names if you wanted to, like 1, 2, 3, 4, 5.
Yep, something like. I love this about Eagle. The command just stays active until you switch to something else. There we are. Okay, and that's basically it. That generates this footprint. So as you can see, leveraging these can make life easier. And you don't have to make the entire symbol this way. You can make a side. You can then rotate it. You can adjust them. So it's really
nice. So like if you had like a 4-sided component, you could do the left and the right and go back and use the pin array again and then do the top and the bottom.
Correct.
Then. Yeah. So that actually helps you create, or you could use it to create each row of a BGA if you wanted to. Even though the BSDL one is actually pretty nice because it's so flexible as well. So the concept today was to show you the exact, the procedure by which conventionally a component would be created by using the symbol, the footprint, and then at the end of the device. But we wanted to demonstrate some shortcuts that are available to build those components a lot easier. So, using the ULP or using the pin and pad array and smart paste on the schematic symbol, yes, reduce the amount of time that you have to spend creating component before actually using it in your design. So I think this is everything we wanted to cover. Did we miss anything, Jorge? I think we're good.
Yeah, I mean, just wanted to show pad array, basically the same thing.
Oh,
So
for through hole. Yeah, for
you
through
can
hole
do it
parts.
through. Works the same way.
Works exactly the same way as the SMD array as well. Absolutely sure. I spaced that out. Now I'd like to go ahead and enter into a Q&A session if anybody has any questions in regards of the library editor or the shortcuts that we've been able to demonstrate today. Well, let's go ahead and take care of those questions.
Let's do it.
Hey, John wants us to make sure that we put this on YouTube. That means that it went well then.
Yeah. Yeah.
Yeah, a lot of these are little shortcuts, but man, they reduce the amount of time making parts. You can
Yep.
go from trying to figure out a specification sheet, which could take several minutes, to doing it to yes a minute. By knowing how to use these shortcuts. Also, remember that you could always contact us through our support email inbox, which is support.eagle@autodesk.com. You're always more than welcome to email us there. Jorge, myself, as well as Rick over in Germany, we monitor that inbox. So you access all three of us through there, as well as if you already have acquired a subscription of Eagle, you could also access us through your Autodesk account and create a case. And we usually, Jorge, myself, or Rick, are attending to the cases online as well. Okay, so.
Do you have time for a completely different question?
If you hear the 3D printer running in the background,
That's because it is.
it's because it is running in the background.
Regarding a 4017 is the best way to get VCC and ground by using the invoke tool. Yes. Almost all of the digital logic in the Eagles libraries is designed following that pattern of the VCC and ground symbol, ground pins being request type gate. So yes, invoke is the best way to bring them in.
Remember that the implicit power pins automatically get connected with other power pins with the same name. So they just bring in too much information onto the schematic. But of course, you could always invoke them. But
Yeah.
that's the reason why we do it that way. That's the reason.
I always invoke them. I trust no one.
Yeah. Yeah. Depending on the density of the design, you could always invoke them. What I've noticed is that many users will actually have a sheet dedicated to all the invoked power pins. So they'll dedicate a separate schematic sheet to that, to all power. Usually, they'll put it towards the bottom of. If it's a one schematic sheet, you'll see that it's at the bottom. They have all their power invoked pins on the bottom, connected to the source.
Okay.
Library loader from Mauser generates a library for Eagle.
I don't know.
Yeah, I haven't. I think
should
there's
play with that.
Yeah, library loader. Who makes that? Who makes library loader?
You just said it, Mauser.
Oh, Mauser makes it. Oh, that's from Samaxis. That's the Samaxis library loader. Yeah. That's the Samaxis tool. Yeah, for Alex from Samaxis, those guys. Yes. Be really, really careful to when you do that tool. I've run into some complicated. It works great. So yeah, continue using it. The thing is that if you bring it into a managed library, things could get a little weird. Okay, it could get really strange. So what I recommend is that you always bring them into a non-managed library. And then once you have it in that non-managed library, you could either, copy it into your managed library or import from within the managed library. You could import it. And as soon as you take that into your managed library, make sure that you create a new version. In other words, you synchronize. Make sure you synchronize, because what happens is that if you don't synchronize and you save the library and then you try to use it, it gets really strange. So if you are working with 3D, if you're working with Eagle and Fusion and you're using 3D models and all that, and you're using managed library, yes, make sure that put it into a non-managed library, copy it into your managed library, synchronize, and then map out your 3D model and all that after that. Okay, so yes, because Semaxis usually includes a lot of times, not always, but they include the step model as well, the majority of times. So that loader works really, really well. I've used it. I have quite a bit of experience with it, as well as I've crashed because I brought it into a managed library and things didn't go well. So just wanted to give you a heads up on that one, John. Okay. Okay. So I don't see any other questions. Appreciate your presence. Hey, Jorge, great job. Thanks again, man. Appreciate that.
Bye, everyone.
Everybody have a great day. Thank you.